Right, so today we're going to be going through the A2 mock paper 2, which was last year's paper 2. So first of all, we've got functions question. So we're going to find GG of that, GG of 5. So with these, remember, work from the brackets outwards, going to get 5, put it into G, and then put that back into G itself. So, make it nice and clear. First, we're going to find G of 5. So we're going to get 2 lots of 5 plus 5 over 5, take 3, which is 15 over 2. We're then going to put that back into G again. So now we're going to do G of 7.5. So we're going to get 20 over 4.5. Which is 4.4 recurring. So 40 over 9. Cool, that's first up. B, state the range. What's the thing we need to remember for these is to sketch them. So we're trying to sketch G of x, 2x plus 5 over x minus 3. There's no excuse for getting these wrong. So we've got basically a 1 over x graph. So we're going to have an asymptote at x equals 3. And to kind of work out the other asymptote, we're going to do 2 lots of infinity plus 5 divided by infinity, take 3. 2 infinity plus 5 is about 2 infinity. Infinity take 3 is about infinity. So we get another asymptote at y equals 2. Alternatively, you can do long division to find the other asymptote, but I'll label these. So we've got x equals 3, y equals 2. And then my curve is going to just go through like this. Cool. And our domain for this is x will be greater than or equal to 5. So that means none of this is actually allowed. So we're going to get from 5 to whatever this value of 5 is down to y equals 2. So if I put 5 in, which we actually did right at the beginning of the question, we get 15 over 2. So we're going to get x has to be less than or equal to 15 over 2. Less than or equal to because the domain is greater than or equal to 5. So if you look at this, greater than or equal, maybe let's redraw this. So we've got 3, 2, x has got to be greater than or equal to 5. So we're looking at whatever this value is down to whatever this value is, which was 2. So put 3 in, get 7.5, so it's got to be less than or equal to 15 over 2. And it's got to be greater than or equal, or sorry, just greater than 2. It can't equal 2 because there's an asymptote. So that's what you need to have for your range. Last bit is find the inverse and state its domain. So remember with the inverse, we want to say y equals 2x plus 5 over x minus 3. We're going to rearrange this to get x equals and then change the subjects over. So times up both sides to get yx minus 3y is 2x plus 5. Get all the x's on one side. So add 3y over, take this over. Yx, take 2x, and equals 3y plus 5. So x, y take 2 is 3y plus 5. So x equals 3y plus 5 over y take 2. So our inverse, g to the minus 1 of x, is 3x plus 5 over x take 2. And it wants us to state the domain of this. So the domain of the inverse is the same as the range of the original. So our domain for this one is going to be x is less than or equal to 15 over 2, more than 2. Or whatever, it's got to be the same thing as you had for the last bit. Cool. Okay, next bit we've got vectors question, which is a little bit trickier. So we're going to sketch this relative to a fixed origin. So we're talking 3D space, so let's just draw a 2D sketch. So point A, which has position vector 2, 3, minus 4. Point B, 4, minus 2, 3. And point C, A5 minus 2. So I put my points on. I know it's 3D, but we can draw it like this. D is the point such that A to B is the same as B to D. So if I say A to B is here, B to D should be about here. Find the position vector of D. So first of all, let's work out what AB actually is. So using the triangle rule, we know A to B is minus A plus B, or OB minus OA. And in a similar way, we can say that BD, if we say that's D up there, we can go back B and then up D. So BD is OD minus OB. And these two things should be the same. So we find AB, put it in there, put OB in there, we can work out what OD is. So AB is 4 minus 2, 3. Take away 2, 3 minus 4. Be really careful of your minus signs on these. So we're going to get 2 minus 5, 7. A lot of you made sign errors there. And that is the same as BD. So I can say 2 minus 5, 7. Keep your layout nice and clear. So there's BD. BD equals OD, which is what we want to find, minus OB, and OB was 4 minus 2, 3. So if I add this on, we're going to get OD. So OD is 2 minus 5, 7, plus 4 minus 2, 3. So add all this, we get 6 minus 7, 10. So that's 2 marks. Next bit, given A to C is 4, the modulus of AC is 4, find A. So A to C, if we go back to our sketch, again using the triangle rule, A to C is minus A plus C. So OC minus OA. So if we find an expression for AC and then set that equal to 4, we can do it that way. So we've got A 5 minus 2, take away 2, 3, minus 4. A take 2 is just A take 2. 5 take 3 is 2. Minus 2 minus 4 is going to be positive 2. And we know this AC, if we modulus this, should equal 4. So we can say 4 equals the square root of A minus 2 squared plus 2 squared plus 2 squared. So square both sides, 16 is expand this quadratic, A squared minus 4A plus 2. 2 squared is 4, 2 squared is 4, so plus 8. So we're going to get a quadratic for a value of A. We also told up here, because it's a quadratic, I can see we're going to get two solutions. A is less than 0. So it's going to be the negative solution to this quadratic. So add those together, we get 10. Take 16 from both sides. We're going to get A squared minus 4A minus 6. Do we get real solutions for this? No, we don't. So if you get that, get your calculator out. Onto your quadratic solver machine and type in 1 minus 4 and minus 6. Hit equals. And I think I've typed it in wrong. What have I done? don't know what I've done. It's been a long day. Let's just go from here. So I'm going to get 16 equals a minus 2 squared plus 4 plus 4. So take those away from the side, we get 4 equals a minus 2 squared. Square root both sides, so we get 2 plus or minus 2 is a minus 2. Oh, something's moving wrong. 16 divided by 8. 16 take 8. Fuck. So, part B, we're told that modulus of AC equals 4. AC is going to be OC minus OA. So, we get A, 5 minus 2, take away 2, 3 minus 4. So, this is going to be AC. So, we get A take 2, 5 take 3 is 2, and minus 2 take minus 4 is also 2. There's AC. We're told the size of AC is 4, so the size of these is going to be the square root of a minus 2 squared plus 2 squared plus 2 squared. So if we try and solve this, we can square both sides. You get 16 equals a minus 2 squared plus 4 plus 4. Take 8 from each side. 8 equals a minus 2 squared. Square root both sides, so we get root 8 is a minus 2. So a equals 2 plus or minus root 8. Now it says a needs to be negative, so it's going to be a equals 2 minus root 8, as a is less than 0. There's our solution. Cool. Right, on to question 3. So question 3 is a proof style question. So if m and n are irrational numbers where m is not n, then mn is also irrational. Disprove this by means of counting sample. So if we make 2 irrational numbers, m could be root 2, n could be root 3, any two really. Counter example, so we're trying to prove that m times n is also irrational. So root 2. No, this is not a good example. Okay, question 3, so proof question. If m and n are irrational numbers where m is not equal to n, then mn is also irrational. Disprove this statement by means of counter sample. So we're trying to prove with 2 rationals you could times them and get a rational number. So if we have root 2 times root 8, first thing pops into my mind, times these together and we get root 16. Root 16 is 4, so 4 is rational. Therefore, statement is not true. It's the first bit done, there's A. Part B, sketch the graph of y equals mod x plus 3. So it's going to be a modulus x graph, which is like this, but moved up 3. So there's mod x plus 3, labelled the values on. So that was 1 mark. Next bit, explain why mod x plus 3, the thing we just drew, is always greater than or equal to x plus 3 for all real values of x. So, I think the best way to do this is to just sketch them. So we've got the sketch already. If I sketch mod x plus 3, well, x plus 3 would be this line. But if we mod the entire thing, all it's going to do is move these bits up. So we're going to get up here, and that crosses at minus 3. So you can see for this, for any real values of x, this one is always greater, or for this portion equal to, but here it's always greater. So we can say is the same or less for all values of x. I think that would do with our graph there. Yeah, so same or above for the other one, or for this portion they're obviously equal, so therefore it is the same or less, equal to or less than. Cool, right, question 4 next. Okay, a little bit tricky this one. We're trying to prove this horrible sum looking thing is that horrible number that. So if I write this out, so try and prove this. The key to this is spotting that you've got sum of 3, sum of 5r, which is going to be a arithmetic series, and 2 to the power r, which is only going to end up being a geometric series. So I would do these all separately. So we'll do 3 first. So basically we've got 16 lots of 3. So 16 times 3 is our first one. So we get 48. Next one, we've got an arithmetic series. So if we do 5r next, the first term, put 1 in, we're going to get 5. Common difference, if we put a few numbers in, we're going to get 5, 10, 15. So common difference is going to be 5 as well. And n is 16. So we get the sum equation, n over 2, 2a plus n minus 1d. So Sn is 16 lots of 10 plus 15 times 5. Which gives me 1360. So we've got 48, 1360. Is that right? Something's gone wrong here. Sorry, that should be an 8, so we need to half that. Tired day. So this should be 680. So 48, 680, and the last bit here it said was geometric, so 2 to the r. First term is going to be 2. The ratio, if we try a few terms, so we're going to get 2 to the power 1, 2 squared is 4, 2 cubed, 8. So the ratio is going to be 2, so r equals 2 as well. And number of terms is 16. So Sn is a 1 minus r to the n over 1 minus r. So 2 lots of 1 minus 2 to the power 16 over 1 minus 2. Yeah, cool. So 1 minus 2 is minus 1, so that over minus 1. So your Sn is 131070. So it's these 3 numbers added together. And if you add them all up, you get 131798 as requested in the initial bit. Cool. Right. Part 2. We're given a recurrence relationship. So we're told un plus 1 equals 1 over un. u1 is 2/3. So we want to find the exact value of the sum from 1 to 100 of ur. Now this isn't a series that we know, so we're just going to have a mess around a bit and see what the values are. So if you find u2, we're going to get 1 over 2/3, which is just a reciprocal, so we get 3 over 2. If we then find u3, it's going to be 1 over this, so it's going to be 2/3 again. So you can see it's just going to flick between these. So the sum of all these is going to be the sum of 50 of these ones and 50 of these ones. So it's going to be 50 times 2/3 plus 50 times 3/2. Which gives us 325 over 3. Cool. Right, next up. Right, so next up we've got a Newton-Rapson formula. So we're trying to prove this for this function. So if I write this out quickly, 2x cubed plus x squared minus 1 equals 0. So Newton-Rapson formula, xn plus 1 equals xn minus f of xn divided by f dash of xn. So we're going to differentiate this, put it here, and try and rearrange this and turn it into this. So f dash x is going to be 6x squared plus 2x. So I write out the Newton-Rapson formula, so we get xn plus 1 equals, I'm just going to call it x now because the ends are going to get a bit messy. So we got 2x cubed plus x squared, take 1 over 6x squared plus 2x. So we need to get common denominator and subtract these two fractions. So in other words, I need to times this x by 6x squared plus 2x. So we get x, 6x squared plus 2x, minus 2x cubed plus x squared, minus 1, all over 6x squared plus 2x, and I'm going to expand all this and subtract each term. So on top, we're going to get 6x cubed take 2x cubed, it's going to be 4x cubed. So 4xn cubed. 2x squared take x squared is going to be plus x squared, so plus xn squared, plus 1, all over 6xn squared plus 2xn, which is exactly what they wanted. Okay, use this formula with x1 equals 1 to find x2 and x3. Should be relatively straightforward. So we get x1 is 1, x2 is going to be 4 lots of 1 cubed plus 1 squared plus 1 over 6 lots of 1 squared plus 2 lots of 1. So we get 4 plus 1, which is 6, divided by 6 plus 2, which is 8. So 3/4 for that one. Slightly harder then, we're going to put 3/4 back in. So x3 is going to be 4 lots of 3/4 cubed plus 3/4 squared plus 1 divided by 6 lots of 3/4 squared plus 2 lots of 3/4. So guess use calculator if you can't be bothered to do it in your head like I can't right now. So 3/4 cubed plus 3/4 squared plus 1 divided by 6 lots of 3/4 squared plus 2 lots of 3/4. And you get 2/3. So those are your two values. Cool. Right, explain why for this question Newton-Rapson method cannot be used if x1 equals 0. Almost all of you got this wrong. So you actually need to think about what the Newton-Rapson method does. So remember, Newton-Rapson method, it's kind of like a sketch of the graph, and it keeps finding successive tangents and where they cross the axes to find new tangents. The problem with this one is it's a cubic there, and there's a stationary point when x is 0. So for this curve, we've got a minimum maximum at 0. So you find the tangent at 0, it doesn't ever cross the x-axis, it's on the x-axis. So because it's horizontal, you can't find a new x-intercept, so you can't find the next iteration along. It's nothing to do with being able to divide by 0, it's to do with the actual curve itself, how the Newton-Rapson method works, and the fact that you can't get an x-coordinate to put back in because you're just stuck on 0. So answers they would accept, you've got the mark scheme here. There is a stationary point, the tangent would not meet the x-axis, or the tangent is horizontal. Stuff you're not allowed, can't divide by 0, fraction is undefined at x is 0, 0, 0, blah, blah, blah. So nothing to the denominator being 0, it's actually asking you about the Newton-Rapson method and how it's calculated. Cool. Right, next up. Functions. So, right, so first thing here is they want to find f of 2, so we're just going to put 2 in. So we're going to get f of 2 equals minus 3 lots of 2 cubed plus 8 lots of 2 squared minus 9 lots of 2 plus 10. And if you work all of that out, you should get 0. So otherwise saying that 2 is a factor. And now we want to write this as a product of two factors. Well, let's just code for use the factor you just found to do some long division. So, long division, hopefully you can remember this. So factor theorem is going to be the opposite, so x minus 2 there. So we're going to do some long division, so minus 3x squared on top. Subtract these to get 2x squared. Then start again. And subtract, so you get minus 5x plus 10. So, we've got minus 3x cubed plus 8x squared minus 9x plus 10 is the same as x minus 2 times what's on top there. So x minus 2 times minus 3x squared plus 2x minus 5. I don't know why I turned that into a bracket. So minus 3x squared plus 2x minus 5. So that's two algebraic factors. Cool. Right, next bit, using this, prove there are exactly two solutions to this. So if we look at these, very similar, although all our powers are increased. So we've got basically x equals y squared. So this basically the only difference is that x equals y squared. So it would factorize as y squared minus 2 and then minus 3 y to the 4 plus 2y squared take 5 equals 0. So either this is 0 or this is 0. If we do the discriminant on this one, which we'll do now quickly, b squared minus 4ac. So b squared is going to be 2 squared minus 4 lots of a is minus 3, c is minus 5. We get 4, take away 60, so minus 36. Is that right? Minus 56, which is negative, therefore no solutions. So that has no roots. This therefore must supply all the roots. We get y squared minus 2 equals 0. So y squared equals 2. So y equals plus or minus root 2. So therefore 2 real solutions. Cool. Right, next bit. This kind of feeds us this again. So deduce the number of real solutions for this trig thing between 7 pi and 10 pi. So again, if you look, we've got the same thing. Minus 3x cubed, well, 3 tan cubed. All the signs are changed, but it's the same equation in theory. So we can just substitute tan instead of x. So here where we solved it, we already said this has got no solution. So therefore, our tan solutions is going to be tan theta equals 2. And we're trying to solve that between 7 pi and 10 pi. So we don't even need to find them, let's just do a sketch. Might be a bit of a small sketch, but whatever. So there's pi. So we could basically skip to it. So 7 pi, I mean, tan repeats every pi anyway, so we could just call this 7 pi if we like. So 7 pi, there's 8 pi. No, it's not, it's 9 pi. And there's 10 pi. So how many times is this equal to? If 2's there, we got 1, let's get rid of this. 1 there, 2 there, 3 there, so 3 solutions. That's all it's asking for. It doesn't care what they are, it just wants to know how many solutions. So 3 solutions for them. Cool. Next bit. So now I've got some trig. Lovely. So we're trying to solve 4 sine x equals sec x for 0 to x, so pi by 2. So first step is change this into cos. So 4 sine x equals 1 over cos x. Times up by cos x to get 4 sine x cos x equals 1. And the trick to this is now spotting that this is twice the double angle for cos. So remember, double angle for cos, double angle for sine. Sine 2x equals 2 sine x cos x. So we've got 4 of them, so we've got 2 sine 2x. So 2 sine 2x equals 1, so therefore sine 2x equals a half. So to solve this, remember back from first year, we need to stretch the limits first. Our new limits are going to be 0 to 2x to pi. Find the primary angle, so sine to the minus 1 of a half gives you 30. So 2x is probably in radians, yeah, it's in radians. So we're going to get pi by 6. So sketch sine from 0 to pi. That's it. So we've got pi by 6 as our first solution. So second solution is going to be pi minus the sixth pi, which is going to be 5 pi by 6. So 2x is pi by 6 and 5 pi by 6. So x is pi by 12 and 5 pi by 12. So those are our two solutions. Cool. Second one, slightly harder. And most of you missed the right technique for this one. So we've got 5 sine theta minus 5 cos theta equals 2. So we've got a sum of 2 trig. You need to remember, to solve something like this, we need to use the R method. R method goes from a sum of trig, or a difference of trig like we have here, turns it into one type of trig with a stretch and a translation, and then we'll be able to solve it. So we've got sine minus cos. So I'm going to look at my addition rule formulae, and we'll choose the easy one, which is sine theta cos alpha minus sine alpha cos theta equals sine of theta minus alpha. So there's our addition rule. We're going to apply that to this. So we're going to compare coefficients. So the sine bit here, actually we need an r here as well, don't we? So r there, r there, r there. So sine theta here, we've got 5 equals r cos alpha. And we can say 5 equals r sine alpha. Cool. So to find r, we're going to square both these, add them together. We know cos squared plus sine squared is 1, so we end up with r squared is this number squared plus this number squared. So r squared is 50, so therefore r is root 50, so that goes there. We need alpha, so we're going to divide these and we'll get tan alpha is 1, therefore alpha is 45 degrees. So the R method says this equation we started off with can be written as root 50 sine theta minus 45, which we're trying to solve to equal to. So all we need to now is solve this between the limits of 0 and 360. So divide both sides by root 50 to get sine theta minus 45 equals 2 over root 50. Change our limits, we're going to take away 45 from each of these, so we get minus 45 to theta, take 45, so 315. Inverse sine both sides, so we get sine to the minus 1, 2 over root 50, which gives us 16.43 degrees. So we know theta, take 45, 16.43. Let's see if there's any other solutions. So quick sketch of sine. So we've got this value here, so the only other solution is going to be here, which is 180. Take that. Which is 163.57. So then to find theta, we're going to add 45 back. So we get 208.57, or we get 61.43. It does say actually give your answers to one decimal place. So it's going to be 61.4 or 208.6. So watch out though, remember to spot the R method if you got two different types of trig being added or subtracted from each other. Right, what's next? Oh yeah, this question. Cool. So again, this one went quite badly. This is a modelling question to do with quadratics. So we've got the trajectory of a rugby ball. Ball reaches a height of 12 meters, so we can label this as 12. And hits the ground at a point 40 meters away from its kick, so we can label this point here as 40. Okay, that's all we're told. We know it's a negative quadratic. Find an equation linking h, the height, that models this situation. So let's draw that out again quickly. Now, there's a few ways you could do this. I think the easiest way is just to look at it. So we know we got a root at 0, a root at 40. A lot of you got that idea and you said h equals, well, you know you have to have an x outside. You know we've got to have a 40 inside, so x take 40. And we know it's a negative quadratic, so you did minus there. What you forgot was, this doesn't guarantee that this point is correct. It might have been stretched vertically. So these points could stay here, you could stretch the graph up, however you like. So we need to account for that. So we're going to say h equals minus ax times x minus 40, where a is going to be our stretch. So at the moment it's not worth 3 marks, we've got to now try and find a. So the maximum point is going to be halfway through, so we know it's going to have a point 20, 12. So if we put in h as 12 equals minus a times 20, 20 minus 40, so literally putting in the point 20, 12 into the equation, we can find out what a is. So we're going to get a equals 12 equals 400a, so a equals 12 over 400, which is 3 over 100. So our height equation becomes this, h equals minus 3 over 100 x take 40. Or you might have put this minus inside and got 3 over 100x, 40 minus x. Same thing though. Right, next bit of that. The ball passes over a horizontal bar, it's perpendicular to the path of the ball. So, bar is 3 meters above the ground. So the height of the bar is 3. We're going to try the greatest distance of the bar from the origin. So basically just need to put 3 into this equation. So we're going to say 3 minus 3 over 100 x take 40. Expand all this, so we're going to get 300 divided by minus 3, so we can going to get minus 100 equals x squared minus 40x. So we're going to get x squared minus 40x plus 100 equals 0. Solve that on a quadratic equation formula, solve the thing. 1x squared minus 40 plus 100. We get x equals 20 plus 10 root 3, or 20 minus 10 root 3. So the greatest distance is obviously going to be the first one of those, which is 37.32. Yeah, it doesn't say anything about accuracy. So that will do 47.32 meters. Cool. Right, give one limitation of the model. You can have a load for this one. So looking at this, does this accurately portray a rugby situation? So is the floor completely flat? Nope. So the ground might not be horizontal. The ball needs to be kicked from the ground. How often does that happen in rugby? I don't actually know. Normally I think they drop it. Ball isn't a particle, so try and find some problems with this. So yeah, the ball won't be modelled as a particle. Horizontal bar needs to be modelled as a line. We model it as a point, or as a line like this. There's no wind or air resistance, there's no spin, there's no obstacles, and the trajectory is a perfect parabola, which again is very unlikely given air resistance. And the shape of a rugby ball, it's not a particle at all. Right, okay, question 9. So first principles differentiation with the small angle approximation. So we're trying to prove d by d theta of cos is minus sine. And they've actually been really nice with this, which hardly any of you used. So you may assume the formula for this, so told us what you do there. And they said as h goes 0, sine h over h is 1, and cos h minus 1 over h is 0. Which makes things really easy. So we're going to use our first principles formula, which says this. If you don't get that right, you're an idiot because you didn't look in the formula book. So f of x plus h is change theta into theta plus h. So we get cos theta plus h minus cos theta divided by h. This we expand with the rule that they told us to use. So we get cos theta cos h minus sine theta sine h minus cos theta over h. And we can split this up now. So they've kind of told us what to do with this. So they've said sine h over h is about 1 and cos h over h is about 0. So what we're going to do then, if we get all the cos thetas together, we can say it's cos theta cos h minus 1, so we factorise out that, minus sine theta sine h, all divided by h. And then we can look at the approximation they gave us on the page. So cos h minus 1 over h is about 0. So cos h minus 1 over h, this is 0. So this whole thing's going to go to 0. So to show this properly, split it up into two terms, cos h minus 1 all over h minus sine theta sine h over h. So that all goes to 0. And this bit, we know sine h over h goes to 1, so this becomes minus sine theta times 1, so equals minus sine theta. So pretty easy. You don't have to do any of these small angle approx stuff. Some of you did, you got the marks anyway, but you ought to use what they give you. They haven't done that for no reason. Right, next up we've got some forming of differential equations and some solving of differential equations. So let's go through this. So spherical mint, radius 5 millimeters, place in mouth and sucked. 4 minutes later the radius is 3. Okay, here's the important bit. The rate of decrease of the radius, so dr by dt, to decrease, so it's negative, is inversely proportional, so 1 over the square of the radius. So we're going to get k because it's proportional, inversely proportional, 1 over square of the radius, r squared. So we need to be able to go from this statement to this equation. Okay, so find an equation linking the radius and the time. So we need to go from this, integrate both sides to get this thing, and it says you should define the variables. There's actually a mark for defining these variables. So if we split this up, we're going to get all the r's here, all the t's here. So we get r squared dr equals minus k dt. Integrate both sides. R cubed over 3 equals minus kt plus c. And we want to find an equation for the radius. So if we times up by 3, r cubed equals minus 3 kt plus c. Now, at this stage, we haven't defined anything. Oh, actually, we don't even need that. That's good enough. So we need to define what these things are. So r is radius in millimeters. T is time in seconds. Let's go for. Cool. And that's all we need. Good. So that's the first bit done. Next bit, hence find the total time. Oh wait, do we need to find? Yeah, we need to find A and B. Of course we do. So at the moment we haven't found K or C, so I need to do that next as well. So they've told us when r equals 5, t equals 4, and when r equals 3. No, what am I talking about? R is 5 initially, and then R is 3 when t equals 4. So we could say t is time in minutes, so I think you'd be allowed that. Because we are literally subbing in minutes. So, my radius then, you'll put both these in and find t and c, solve them simultaneously. So we're going to get 5 cubed over 3 equals 0 plus c. So therefore c is going to be 125 over 3. And put this in as well, so r is 3, so 3 cubed over 3 equals minus 4k plus 125 over 3. So that's my c that I just worked out. So 3 cubed over 3 is just going to be 3 squared, which is 9, equals minus 4k plus 125 over 3. And if you work it out, you get k is 49 over 6. So put all that back together, r cubed over 3 equals minus 49 over 6t plus 125 over 3. So that is an equation linking r and t, where t is the time in minutes and radius is the r is the radius in millimeters. Right, hence find the total time for it to completely dissolve. So it will completely dissolve when r is 0. So we want to find t when r is 0. So put in r is 0. 0 equals minus 49 over 6t plus 125 over 3. Add this over, 49 over 6t is 125 over 3. So therefore t is 125 divided by 3 divided by 49 over, oops. So we get t is 250 over 49. Now that is minutes, so we've got 5.1 mins. So in other words, it's 5 minutes and 0.1 times 60, which is 6 seconds. You do need to give it in that form. It does say minutes and seconds to the nearest second, which is that. Okay, last bit, suggested limitation. There's quite a few of this, so I'll go through the ones that give you in the mark scheme, so you guys have got them all. So, doesn't consider how it's sucked. That's, yeah. Doesn't consider whenever it's bitten. Doesn't, limited for up to 5 minutes, 6 seconds. That's only valid for those times. After that, the mint looks like it's negative, which is mentioned later on. Mint may not stay at the same shape, so that would change it. It might not have a uniform radius. The model suggests the mint goes negative radius after it dissolves. Doesn't consider temperature, doesn't consider the rate of saliva, and it can be swallowed. Okay, so you can't accept, may not dissolve at a constant rate, you've got to give a reason. Do not accept, rate of decrease must be constant. You can accept these with some of this other stuff, but it needs to really be linked into the context of a mint dissolving. Right, how many we got left? 4. Right, next one. Let's do the rest tomorrow. Bye. Right, so on to question 11. So this is a partial fractions kind of question. So let's write it out. Cool. All right, so you should be able to notice we've got a quadratic on top and a quadratic on bottom, so we're going to need to do long division to find the constant a. So if we expand the bottom and do some long division, cool, there we go. All right, so we're going to do minus 6x squared divided by minus 2x squared, which is going to give us 3. And we'll multiply to see what's left. So minus 6x squared. Oh. Plus 21x. Subtract these. They cancel out. 11 take 21 is going to be minus 10x. Drop down. Oh, and 3 to the lowest 3 minus none. So plus 10. So we get this whole fraction becomes equals 3 plus minus 10x plus 10 over x minus 3 1 minus 2x. So we've got the 3, that's a. We just need to split this into partial fractions to find b and c. So we'll say minus 10x plus 10 equals b times 1 minus 2x plus c times x minus 3. So if we let x equal a half, we will get minus 10 times a half plus 10 equals c half take 3. So we're going to get 5 equals minus 5 over 2c. So if we rearrange this, 10 is minus 5c, therefore c equals minus 2. Right, and then to find b, we're going to put in let x equal 3. So we're going to get minus 30 plus 10, which is going to be minus 20, equals b times 1 minus 6. So minus 20 equals minus 5b, so therefore b equals 4. Cool. Right, so that's a, b and c. A is 3, b is 4, c is minus 2, and then we want to prove it's a decreasing function. So to prove it's a decreasing function, we're going to differentiate. Now, we may as well use what we just found out. So differentiating this would be horrible, but differentiating this wouldn't be so bad. So if we write it out in terms of a, b and c, we get 3 plus 4 over x minus 3 minus 2 over 1 minus 2x. So we've got to differentiate this. This is f of x. Try and prove it's decreasing, so we're expecting the gradient to come out as being negative at all points. So differential of this, 3 differentiates to 0. This we can write as for x minus 3 to the minus 1. This we can write as minus 2 or minus 2x to the minus 1. So a lot of you got this wrong and you kind of went for I don't know what you guys did, but yeah, a lot of this went wrong. So we're trying to differentiate this. So remember, taking 1 from the power. A lot of you think integrate this. So we're going to get minus 4x minus 3 to the power minus 2 plus 2 times 1 minus 2x to the power minus 2. Cool. Sorry, I'm being an idiot here. We've got to do the inside as well. So we get minus 2, so it would be plus 2, but then this comes out, so it becomes minus 4 there. So we've got a negative. If you put in x, no matter what it is, x is going to get squared, so this is always going to be positive. Times negative, this is always negative. Again, put in x, it gets squared, always positive. Times negative, always negative. So yeah, we can say f dash of x equals minus a positive, therefore always negative. therefore decreasing function. Cool. Right, next one is onto trigonometry. We've got a trig proof, and then we've got to do some trig solving. Cool. Alright, so trig next. We've got to prove that 1 minus cos 2 theta is the same as tan theta sine 2 theta. Right, so with this one, few options really. We could use the left hand side or we could use the right hand side. I think for this one, it might be easiest to deal with the right hand side first. So if we say tan theta is sine over cos, so we get sine theta over cos theta times by sine 2 theta. Sine 2 theta we know is 2 sine theta cos theta. So we can put that in here. So sine theta over cos theta times 2 sine theta cos theta. So coses are going to cancel. We're going to end up with 2 sine squared theta. And there is a double angle formula that links cos 2 theta and sine squared. So we can put that over here. Cos 2 theta equals 1 minus 2 sine squared theta. We've got 2 sine squared theta, which is just cos 2 theta minus 1. So we can just say that equals cos 2 theta take 1. So nice and easy there. Next bit, hence solve this other thing. So we're trying to solve sec squared x minus 5 times 1 minus cos 2x equals 3 tan squared x sine 2x. And what we just proved was this bit. No, wait, what was I talking about? Sorry, I just finished that bit wrong. That should be 2 sine squared is 1 minus cos 2 theta, not y, right? So what we just proved was that 1 minus cos 2 theta is tan theta sine 2 theta. So we can change here into tan theta sine 2 theta. And we're trying to solve when this equals 3 tan squared sine 2x. Well, if we look at this, we've got some of this, we've got sine 2x, we've got tan here. So this thing here, for this to be equal, this bit must equal 3 tan theta, because that's all we're left over here. So we can say sec squared minus 5 has to equal 3. I've mixed up thetas and x's, it's not very good, is it? Make those x's. So yeah, sec squared minus 5 should equal 3 tan x, and if we times those together, then we get to this. So this is what we're really trying to solve. So if we turn this all into tan, we can use the identity and say that sec squared equals 1 plus tan squared. So we can put that into our equation here. So we get 1 plus tan squared minus 5 equals 3 tan x. So in other words, tan squared x minus 3 tan x minus 4 equals 0. So if we solve this, it will give us our solutions for when these two things are equal. So we've got a quadratic as always calculator for that. So polynomial quadratic, 1 tan squared minus 3 tan minus 4. So tan x equals 4, or tan x is minus 1. And we're trying to solve it for the limits minus pi by 2 to x to pi by 2. So do a quick sketch of tan. That's tan for our limits, so we're not going to get many solutions. And if we do inverse tan of 4 and inverse tan of -1, making sure we're in radians, so we get x equals 1.326 to 3 decimal places, which is less than pi by 2. We're not going to get any other solutions here. And if we do tan to the -1 of -1, we get x equals -1/4 pi, which are our two solutions. Cool. Right, next question. Is this lovely area integral question. So let's do a quick sketch of this. So let's see, we've got a line, we've got an area here that we want to try and find. So this point P is EE, and that's everything. Okay, so we've got a line, or we've got a curve, y equals x ln x, and we've got a line which is a normal at EE. Cool, so first of all, let's try and find the equation of the line. And if you can, hopefully you can spot this. We've got a curve, which is going to give us this area here. So if we integrate the curve, we find this little bit here. Let's just draw in. And then we're going to need to add on the area of this triangle, which we're going to find by finding where this line cuts the x-axis. So it's up to you what you do first. So you can do the integral first, or you can do the line. I think let's do the line first. So we first, because it's the normal, we need to find the gradient of the curve, which will get us the tangent gradient, the negative reciprocal of that to find the gradient of the normal, and then use the point E to find our line. Then we can find where it crosses the x-axis. So first of all, we need to differentiate our line to find the gradient. So it's going to be a case of product rule for this one. Let's write it all out. So u equals x, v equals ln x. So we get u dv dx, that's going to be 1 plus v du dx. So our differential is 1 plus ln x. We want to find the gradient when x equals e, because that's the point we're looking for. So putting that in, we're going to get 1 plus ln of e. Ln of e is 1, it's not 0 as a lot of you thought in the test, so we get a gradient of 2. So that's the gradient for our tangent. So our normal is going to have the gradient minus a half. And we know the point here is EE, so if we work out our equation, it's going to be y minus e is minus a half x minus e. So you get y minus e minus half x plus e over 2, y equals minus half x plus 3 over 2 e. Alright, we didn't actually need to do that, but we just want to find out where this crosses x. So we're going to make y equals 0 in this case. So we get half x is 3 over 2e, so we get x equals 3e. So we cross the axis here at 3e. We know this point here is e, and we know the height is e as well. So I can straight away find the area of this triangle, so half base times height. So the base has a length of 2e, and the height is going to be e. So we get an area of this, half 2e times e, which is going to be e squared. So that's our triangle area. Right, now for the integral area, so we need to integrate from where this curve crosses to e. And our curve is either going to cross at, if we work this out quickly, we've got y equals x ln x. We want to find where it crosses the x-axis. We're going to make y equals 0. So 0 equals x ln x. So either x is 0, but clearly it's not that point because that's this intersection, or ln x is 0. Ln x is 0 when x equals 1. So I know that my intercept here is 1. So we need to integrate x ln x from 1 to e. And this is going to be by parts because we've got a product of two things. So u is going to be ln x. Remember, u equals late. dv dx equals x. So u dash is 1 over x. V is x squared over 2. Put these into the by parts equation, so uv minus the integral of v du dx. So we get x squared over 2 ln x minus the integral of x squared over 2 times 1 over x dx. So minus the integral of x over 2 dx. Okay, if we do this integral then, x squared over 2 ln x minus x squared over 4. Limits were 1 and e. So put e in first. E squared over 2, ln e is just 1, so that stays as that. Minus e squared over 4. Subtract the other limit. The other limit, we're going to get ln of 1, which is 0, minus a quarter. So we get e squared over 2 minus e squared over 4 plus 1/4 as our area. Right, so the last bit is to add this. So that's our integral area. Add that to our triangle area, which is e squared. And this is going to give us the exact area in the form they wanted. So they want it in the form ae squared plus b. So we've got half e, take a quarter e, plus e squared. So half take a quarter is going to be a quarter, plus e squared is going to be 5 over 4 e squared, plus 1/4 for 10 marks. Cool. All right, last question, which was on exponentials. Right, so we've got scientists studying some mice. Seems like a very familiar question. So we've got n equals 900 over 3 plus 7 e to the minus 0.25 t. Okay, so first of all, we're going to find the number of mice in the population at the start of the study. So start of the study is when t equals 0. So we're going to get n equals 900 over 3 plus 7e to the 0. In other words, it's going to be 900 over 10, which is 90. Right, part B, show the rate of growth is given by that equation. So we need to differentiate this. So n equals all this stuff. In other words, I would so best bet is to bring up this as a negative power. So we're going to get n equals 900 3 plus 7 e to the minus 0.25t to the power minus 1. So we've got to do some chain rule for this. So let's differentiate the inside first, and then we'll think about what the outside of this goes to. So dn by dt. Inside then, 3 disappears, 7e to this, we get, this is all going to come down. So we're going to get minus 0.25 times 7 e to the minus 0.25. So that's our inside of the function differentiated. Times by the 900 is going to stay there. We're then going to get the minus 1 come down the front, so times by minus 1. And then we're going to get this to the power minus 2. So times by 3 plus 7 e to the minus 0.25 all to the power minus 2. So that's our full expression. We need to simplify this and try and get it into something in terms of n. So if we look back at our original function, we are still going to have, if we simplify this first then, so we're going to get, so minus 900 times, let's get rid of the minus there, so minus there, cancel. So we can get 7 over 4 e to the minus 0.25 all over 3 plus 7 e to the minus 0.25 squared. So, getting there, we somehow need to turn this back into, in terms of n. So we've got n, Should have 300 minus n there as well, divide 1,200. Okay. So, alright, so we're trying to prove this equals n 300 minus n over 1,200. Cool. And we know n, if I write this at the top this time, is 900 over 3 plus 7 e to the minus 0.25t. Alright. So basically I'm going to break this up, rearrange it to try and get it in terms of n, and then hopefully factorise it and get this out the end. So first thing I'm going to do is break it apart and find, because I can see there's 900 over that. We just got squared here, so I'm going to split this up into two fractions times together. So 900 over 3 plus 7 e to the minus 0.25t times 7 over 4 e to the minus 0.25t over 3 plus 7 e to the minus 0.25t. So this is just n. So dn by dt equals n times, and we got all this other stuff. Cool. Right, now what I'm going to do is rearrange this, because I can see we've got the numerator here is the numerator here. So rearrange this just to find what this equals in terms of n, drop that n, and then do the same for the numerator as well. So if I take this over here and do it slightly differently, we can say n is 900 over 3 plus 7 e to the minus 0.25t. So if I want to get this bottom bit on its own, I can times up there and divide down by n. So 3 plus 7 e to the minus 0.25t is 900 over n. So the denominator here is 900 over n. We're dividing by that, so I'm just going to flip it and say this is times by n over 900. Right, so the last bit I need to change into n is this part. So if we look back up to here, again, we've got this bit is here, we've got an extra factor of 4, and we've got this 3 to deal with. So if I take 3 from each side, we're getting closer. Again, it's very close. So we basically got a quarter of this. So if I write that in instead, we're going to say 7 over 4 e to the minus 0.25t equals 900 over 4n minus 3 quarters, which is the last bit to put into this equation. So dn by dt equals n times n over 900 times 900 over 4n minus 3 quarters. So all I need to do is rearrange this and get it into this somehow. Cool. So let's sort this out. So n squared over 900 times 900 over 4n minus 3 quarters. So timesing this out, 900 is going to cancel. We've got 4 on the bottom, n on the top. So n over 4. And we're going to have minus 3n squared over 4 times 900, which is going to be 3,600. So all I need to do now is get this in terms of this, which is getting pretty close to it, I think, I hope. So if we take out a factor of n, actually let's find a common denominator first. So we want to get a common denominator between 3,600 and 4. I think an easy one would be to get 3,600 on both there. So we can say dn by dt is 900n minus 3n squared all over 3,600. Now this is all divisible by 3, so dn by dt equals 300n minus n squared over 1,200. I think I've got it. Now we're going to factorise out the n to get dn by dt equals n 300 minus n over 1,200, which is what I needed to prove. Right, what was the rest of the questions? Oh, there's only 4 marks. That's horrific. Right, let's do the rest of this then. So rate growth is a maximum after t months. So find, according to the model, the value of t. So we need to differentiate this, set it equal to 0, and go from there. Now, very subtly, the rate of growth is a maximum, and here is just the number of mice. So the rate of growth is this. We're talking about the maximum of the rate. So the maximum of the rate is going to be the differential of the rate, which is, in other words, d2n by dt squared, which is what I need to find, and that should be equal to 0. So our n equation, dn by dt, if I expand it all again, we get 300n over 1200 minus n squared over 1200. We can differentiate this, so d2n over dt squared is going to be 1/4 minus 2n over 1200, 1/4 minus n over 600. That's a maximum, so that should equal 0. So in other words, 1/4 equals n over 600. So n equals 600 over 4, which is going to be 150. So that's the n value when it's a maximum. We want to find the time in months, so we're going to put 150 back into our n equation from the beginning. So n equals 900 over 3 plus 7 e to the minus 0.25 t, and n is 150. So if, what should we do for this one? So 900 over 150 equals 3 plus 7 e to the minus 0.25 t. We can take, does it want exactly? No. So 900 divided by 150, take away 3, divide by 7, gives us 3/7 equals e to the minus 0.25t. So we can log both sides. And divide by 0.25. So ln 3/7 divided by minus 0.25 equals t. So into the calculator with that. And we get t equals 3.39. Or 3.4 months. Right, last bit. The maximum number of mice on the island is p. Find the value of p. Okay, so looking back at our n equation, and there's a few ways we could approach this one. So 900 over 3 plus 7 e to the minus 0.25 t. So let's just think about what this graph looks like. So it's an exponential graph. It's a negative exponential. Which has, we will basically, if we're dividing 900 by the denominator, we want to work out what the maximum minimum of this is to work out what the maximum minimum of the denominator is to work out what the maximum minimum of the number of mice is. So the we want e to be a minimum. So we can work out what goes on here now. E tends towards 0. It's never exactly 0, but it does tend towards 0. So if we assume e goes to 0, 7 times e will be 0, so our maximum will be 900 divided by 3. Any other e value will get 900 divided by something closer, something bigger, which will be a smaller overall value of n. So assuming that goes to 0, you get 900 divided by 3, so our maximum number of mice is just 300. So one marker, state the value p, 300. Cool, right, that's it.